Hello, welcome to CashcroftTV. My name is Kalen Ashcroft. I wanted to present you with a mathematical concept or tool that I've been thinking up of for the last couple of years. I just wanted to sort of present it to the world and see if anyone might be able to find use of it or might be able to ameliorate it. So here it is. So I called it Cashian subfunctions. That's the name of the concept. Cashian would be the actual name, and it's derived from my name, Kalen Ashcroft. If someone doesn't like the name, or if someone thinks this might be a tool better fitted under a different name, I'm okay with that. Whether for marketability or whether for parallelism, that's fine. I'm happy to change the name. Either way, here's how it works. So you start with a basic unadjusted function. So we'll call it f of x naught. So in this case, f of x naught equals y equals x plus 1. So very simple, straight line, a slope of 1, and shifted up by 1. Very simple. So the first derivative of that is y equal, or 1 is the first derivative. So with that, you come up with a sub function, a Cashian sub function. In this case, we're going to use x squared as the sub function. With a gamma, I chose the variable gamma. I know it's been used other places in mathematics, but gamma is has the shortest wavelength in the electromagnetic spectrum. So what this means is, and to bring it further, so after you have your derivative and the sub function, you combine them. So f of x Cashian prime is essentially a straight line, the derivative of 1, with a subfunction of x squared over a gamma of 1. If the gamma had equaled 2, it would have been a x squared over every 2. If gamma had been 0.5, it would have been an x squared over every 0.5. But either way, after that, you can't just take the integral of this because it wouldn't work that way. What you have to do is simply graphically shift it over. So bringing back to the non-derivative version of the x squared with the subfunction embedded, it is y equals x plus 1 with an x squared over every 1, because the gamma is 1. So I'm sorry that the drawing is difficult. I drew this with a trackpad on Painter, but either way, this is how it works. And obviously the original function could be different. Original function could be x squared, for example, and the subfunction could be even x cubed, for example. So over every 1 on an x squared function, on a quadratic function, there is a cubic-like behavior, which would almost be like a sinusoidal action up among the gradient or the exponential growth. So in terms of applications, I think it will be very useful in terms of engineering. For example, like a combustion engine, obviously, if you were to measure the speed of a car, it seems constant, but it's actually the amalgamation of many different small bursts or combustions. Similarly, like for example, a pulley or a lever or any situation where the force isn't exactly constant. And I would even go so far as to say in almost any situation or any function, if you were to take a micro enough look, you will find Cashian subfunctions. So I think this would be useful in terms of precise engineering calculations. Similarly, in terms of physics, for example, nuclear fusion and nuclear fission, obviously it could be calculated as a clean sort of straight line or exponential line. But if you look closely at, for example, a nuclear fusion reaction, there are many small fusions occurring that amalgamate to create the heat. So that would have an application there. And similarly, in terms of chemistry, any sort of reaction, if you were to look at it closely, there are many microactions or subfunctions, and this would be a nice way of graphically explaining it by, for example, you could keep the function like this. This is, or like for an example, an exponential decay, to take a chemistry example. But within it, you can have a Cashian subfunction. So within the decay, it's sort of like it might be, I don't know, any sort of subfunction. So it would just be a more precise way of expressing information. In terms of healthcare, one could, for example, measure their perspiration. Obviously, it's when they inhale, it's not perfectly even as they inhale. But even, for example, in physiotherapy, an athlete, when they run, obviously their speed is obviously not a constant. Every time they push off, they get a speed boost, and as they glide through the air, they slow down. So sort of like a negative x squared sort of, or more like a decay sort of process under each certain under each gamma, depending on what the gamma is. And then in terms of computers, as you can hear my computer with the fan going off now, how does for example, the fan might be affecting some of the inner hardware. Similarly, the energy as it goes into the computer. There are many useful applications here, and as we get more and more precise with microprocessors, sub-functions might start to become more meritorious. So I hope this made sense. What I'm trying to express, essentially, it is a way of expressing on a more micro level, on a specific gamma, what is going on within functions, and it would be called a Cashian subfunction. So I hope you enjoyed this video. I hope someone might see this, might be able to either use it or ameliorate it, and yeah, I hope you enjoyed it. Thanks so much.